Greetings of the day, dear students. In this video, we are going to discuss about the earthing or grounding, right? By the time we complete this video, we are going to see what do you mean by earthing or grounding and what is the necessity of earthing, like how to protect the operational person from the dangerous shocks and how to maintain the line voltage under unbalanced load condition, how to avoid the risk of fire due to earth leakage current. Like this we will see or discuss about the necessity of earthing, and also we will discuss about the different methods of earthing like plate earthing, pipe earthing, rod earthing, strip or wire earthing. We will see in detail with illustrative figures about the plate earthing, pipe, rod earthing and also wire earthing, and we will discuss about the selection of earthing on based upon which applications and which type of earthing is to be selected, and at last we will discuss the difference between the earth wire and neutral wire in this video. This is what we are going to cover in this video, right? Yeah. Dear students, with respect to the earthing, the process of connecting the metallic frame of electrical equipment or some electrical part of the system to the earth is called grounding or earthing, right? So here some part of the some electrical part of the system, right, will be connected to the earth. That is called grounding or earthing. Now its main purpose is the potential of the earth. Now its main purpose is to bring the potential of the body of the equipment to zero, that is to the earth's potential. Once if you bring the potential of the body to the earth potential, it is going to protect the person who is operating that equipment against the electrical shocks. Now here the potential of the earth is to be considered zero ideally for all practical purposes, right? The potential of the earth is to be considered as 0 volts for all practical purposes. Now earthing is to connect any electrical equipment to the earth with a very low resistance wire, making it in order to attain it the earth's potential. So by making such kind of connection, this will ensure the safe discharge of electrical energy due to the failure of the insulation line coming in contact with the casing, right? Now the resistance, earth resistance will get affected by the following factors. It also depends upon the material properties of the earth wire and the electrode, and also it depends upon the temperature and moisture content of the soil. It also depends upon the temperature and moisture content of the soil. It depends upon the depth of the pit and the quantity of charcoal we have used. While making the earthing connection, these are all the arrangements we have to make, and we have to take care about all these properties, right? Now here, with respect to the necessity of earthing, it is going to protect the operating person from the danger of the shock, and in order to maintain the line voltage constant under unbalanced load condition, this earthing is required. For example, if there is any three-phase load is connected to the system, whether it is connected in a star manner or delta manner, if there is any unbalanced condition occurred, right, it results in some amount of current flowing through the neutral wire, right? As long as the system is perfectly balanced, the current flowing through the neutral wire will be 0, right? So in order to avoid if any unbalanced condition is there, right, in order to maintain the load line voltage constant under unbalanced load condition, this earthing will be useful, and also to avoid the risk of fire due to earth leakage currents through unwanted path. If there is any amount of leakage current is there that will pass through the equipment body, right, it leads to some rise in the potential of the equipment body. Then as and when if a person touches that equipment, he will undergo electrical shock. So if the equipment is properly earthed, right, then we can avoid electric shock. And also in order to protect the equipments and for the protection of the large buildings and all machines, right, which are fed from the overhead lines against lighting strokes, also this earthing will be useful. So this is the importance or necessity of earthing. Now coming to its methods, what are the different methods we are having, right? We will discuss here. It is a plate earthing, pipe earthing, rod earthing, strip or wire earthing. Now if it is plate earthing, so this is the arrangement you have to make. We will have a earthing copper plate, we will have earthing copper plate, right? This is earthing copper plate, and surrounding that we used to have charcoal and salt mixture. Rock salt and charcoal will be mixed together, and this earth plate should be surrounded with the help of this charcoal and mixture. All these arrangements are made in order to reduce the resistance, in order to bring the resistance to as much low as possible, so that we are going to provide high conducting path through the earth wire. If the resistance offered by the earth wire is more, right, it cannot give you the proper protection. The resistance offered by the earth wire or earthing system should be as much low as possible. It should be as much low as possible, right? Here we are having a galvanized iron pipe, and this is the ground level, right? Ground level, and we are having a cast iron cover, and all these arrangements is made at a depth of some 3 meters, nearly some around at a depth of 10 to 11 feet depth. We have to insert this copper plate. Coming to its physical dimensions while selecting the plate earthing, the copper plate dimensions will be around some 60 centimeters, 60 by 60 by 3.18 centimeters, right? And the GI plate, galvanized iron plate, dimensions will be around 60 centimeter, 60 by 60 by 6.35 centimeters will be used for earthing purpose, right? The plate is buried into the ground not less than 3 meters from the ground level. It should be above, you should not insert the plate within a distance of less than 3 meters. You should insert at a depth below 3 meters from the ground level. That precaution we have to take, right? Now this earth plate will be embedded in alternate layers of coal and salt for a thickness of 15 centimeters. That is what I have told you earlier, right? In addition to that, water will be poured in this arrangement in order to bring the resistance, electrode resistance value below 5 ohms. In order to reduce the resistance, right, you will pour some water. Because of that, what happens is the resistance will get reduced, right? After making all these arrangements, the earth wire is securely bolted to the earth plate, and after finishing all those things, you will enclose in a cement chamber, right, is with a cast iron cover. At last, on that you will make it covered with cast iron cover for easy and regular maintenance, So dear students, with respect to the plate earthing, the important things are, you have to select a copper plate of given dimensions and GI plate, and it should be buried at a depth of not less than 3 meters, and it should be surrounded with a rock salt and charcoal, and later on that you will pour some water. Finally you will cover it, right, with a cement masonry, and over that you will place a cast iron cover for easy and regular maintenance, right? So this is what all about the plate earthing. Now if it is pipe earthing, you have to use an earth electrode which is made up of GI pipe of 38 mm in diameter, and its length should be of 2 meters, and it is going to have some 12 mm holes on the surface. Is placed upright at a depth of 4.75 centimeters in a permanently wet ground. It is to be placed in a permanently wet ground, right? So like this the arrangement will be made. You will have a earth wire, and this is the GI pipe, and this is filled up with salt filled structure, rock salt, and here you will have the charcoal, and this is the GI pipe, and all this arrangement will be inserted in a wet surface, right? So here if you observe, to keep the value of the earth resistance at the desired level, right, the area surrounding the GI pipe should be filled up with a mixture of salt and charcoal. It should be filled up with a mixture of salt and charcoal, which is going to reduce the resistance, earth resistance, right? By making this arrangement, the earth resistance will be reduced. Now the efficiency of the system, the efficiency of this entire earthing system can be improved by pouring water, right, through the funnel periodically. You have to pour some water in order to maintain that pipe earthing system. Now the GI earth wires of sufficient cross-sectional area of 12.7 mm diameter pipe from the 19 mm diameter pipe and secured tightly at the top, right? When compared to the plate earth system, the pipe earth system can carry a large amount of leakage currents due to large surface area in contact with the soil for the same given electrode size, So its meaning is, it is going to offer less resistance compared to the plate earthing system for the same dimensions, right, for the same given electrode size, right? It is going to offer less resistance. Because of that, it is going to allow more leakage current to pass through the earth wire. More leakage current will pass through the earth wire. So this is the pipe earthing, and next one is the rod earthing. It is also same method as pipe earthing, but a copper rod of 12.5 mm, which is nothing but some half-inch diameter, or 16 mm diameter of galvanized steel, in the sense some 0.6 inch diameter of galvanized steel, or a hollow section, some 12 mm hollow, which is in a hollow in nature, a hollow section of 25 mm, nearly 1 inch of GI pipe of length above 2.5 meters will be buried upright in the earth manually or with the help of some pneumatic hammer. Now the length of the electrode embedded in the soil is going to reduce the earth resistance to the desired value. Whatever arrangements we are doing, all their purposes are to reduce or to offer as much low resistance as possible, because if once the resistance is as much low as possible, more amount of leakage current, right, can pass through the earthing system. The more amount of leakage current can pass through the earthing system, right? For that sake, every time you are making use of charcoal, salt and wet watering system arrangement, all those things we are using, right? And the materials also you are using is of copper rod or some galvanized steel or galvanized iron pipes. These are the materials we are using in the earthing system, right? Yeah. Next one is the strip or wire earthing. In this method of earthing, the strip electrodes of cross-sectional not less than 25 mm by 1.6 mm is buried in a horizontal trenches of minimum depth of 0.5 meters, right? If a copper with a cross section of 25 mm by 4 mm, that is used and a dimension of 30 mm square, 3 mm square, if it is galvanized iron or steel will be used, depending upon whether you are using a copper or galvanized iron. The specifications are given, right? And they will be buried in a depth of minimum depth of 0.5 meters, right? If it is copper, the cross sectional dimensions are 1 inch by 0.15 inch. If it is galvanized iron or steel, okay, so some 3 mm square will be used. So depending upon the material you are using, these things are to be preferred. Now if at all round conductors are used, their cross sectional area should not be too small, right? Say less than 6 mm square if it is galvanized iron or steel. The cross sectional area should not be very less, right? It should be as much more as possible. And now the length of the conductor buried in the ground should give a sufficient earth resistance, and this length should not be less than 15 meters. Here you have to go for a more depth. In the previous cases the depth is only just around some. If you observe for plate earthing, you have gone to a depth of 3 meters, not less than 3 meters if it is plate earthing. But if you observe here, the depth is very more. In rod earthing, you should go to a depth not less than, in a stripe or wire earthing, you should go to a depth not less than 15 meters. We should go to a depth of not less than 15 meters. Up to there the arrangement should be made, right? Now the electrodes shall be widely distributed as possible in a single straight or circular trenches radiating from a point. This type of earthing will be used where we are going to have a rocky soil and the excavation or digging work is very difficult. Then you can go for the strip or wire earthing method. If the earth is soily in nature, then other type of earthing can be preferred. But if the earth is rocky in nature and where the digging of the earth or excavation work is difficult, then you can go for the strip or wire earthing. Now coming to its selection, how the selection of earthing will be made depends upon the many factors such as the type of the soil, type of the installation, right? For example, the plate earthing will be preferred for large installations such as transmission towers, all substation generating stations. At all those points you are going to go for a plate earthing. For domestic installations such as for heaters, coolers, refrigerators or geysers or some electric iron boxes, we can go for the pipe earthing system. For 11 kV by 400 volts distribution transformers also, we can go for the pipe earthing system. For induction motors rating up to 100 HP, this can be preferred. For conduit pipe in a wall, for all wall brackets, this type of for all wall brackets, right, pipe earthing can be preferred. Whereas the rod earthing will be preferred in the areas where the soil is loosey or sandy in nature, and at that time you can go for the rod earthing. And if the area is rocky in nature, then we can go for the strip of wire earthing. So these are the methods or selection of the earthing, right? We are having plate earthing, pipe earthing, rod earthing and a strip of wire earthing. Depending upon the applications, we can go for the selection, right? Yeah. Now coming to the earth resistance, the resistance offered by the earth wire should be as much low as possible, so that the neutral of any electrical system which is earthed will be maintained almost at the earth potential. This is very, very important. Now how much should be the value of earth resistance? How much should be the minimum value to be maintained? How much should be the value? For example, the typical value of earth resistance at lower power stations will be around 0.5 ohms. For major substations it will be 1 ohm, and for small substations it is 2 ohms, and for all other cases it can be 5 ohms. Now depending upon the wire, for example, the earth resistance of the copper wire will be 1 ohm, and for galvanized iron wire will be less than 3 ohms. Right? Now, as we discussed earlier, the resistance of the earth is going to depend upon the following factors like condition of the soil, moisture content of the soil, temperature of soil, depth of electrode at which it is embedded or inserted, right, and the size, material and spacing of the earth electrode. We have discussed the length, depth, length, breadth and height of the dimensions of the copper or galvanized iron materials, their size, material and spacing of the earth electrode, and also the quality and the quantity of coal and salt in the earth pit, which grade of coal you are using, right, and the quality and quantity of the rock salt we are using. All these factors, right, will decide the resistance of the earth pit, will decide the resistance of the earth pit or earthing system. So these factors are important. These are to be highlighted. What are those? Condition of soil, moisture content of soil, temperature of soil, depth of electrode at which it is embedded, size, material and spacing of earth electrode, and the quality and quantity of the coal and the salt in the earth pit will decide the resistance of the earthing system, right. So this is what all about the earthing. So dear students, we have discussed in this video about the earthing. What do you mean by earthing or grounding? What are the factors that is going to affect? What is the necessity of earthing, right? And also what are the different methods we are having? What should be the physical dimensions? At what depth they should be inserted? And what are the materials to be used like coal, charcoal, and how they should be covered, right? For all these things are in order to maintain the low earth resistance. Once the resistance offered is low, right, it will provide more conducting path for the leakage current to flow. Once there is a conducting path for the leakage current to flow, it will not pass through the person who touches the electrical equipment, right. Now the already we have discussed about one protective device like earth leakage circuit breaker, where it is going to protect the human person or operators from electric shock by detecting the earth leakage currents. Depending upon the potential difference that is established between the person and the equipment surface, some amount of current will flow, and also it depends upon the resistance of the human body, and also it depends upon the resistance of the human body also varies whether his skin is dry skin or wet skin, whether he is having a dry skin or wet skin while during the period of touching the electrical equipment. Based on that also the resistance offered by the human body will change, right. So if there is no proper earthing, it leads to a severe shock to the persons. Proper earthing system should be there, right. And also we have discussed the what is this applications, for what applications which type of earthing should be preferred, right, depending upon the nature of the soil. If it is soil is sandy or loosey in nature, rod earthing is preferred. If the surface is rocky in nature, then wire earthing is preferred, like that. Now earth resistance, how much should be the numerical values, the range minimum values should be how much, and also the one more important point that left out is earth wire and neutral wire. Earth wire and neutral wire. Dear students, for example, if you are having a three-phase load, right, which is connected in a star manner, the load is connected in a star manner, right, and if you are having a three-phase source, right, now as long as the system is balanced, there won't be any current flowing through the neutral wire. Now if there is this is the neutral wire and this is the R phase, right, Y phase and B phase. So these 2 points will be connected with the help of a neutral wire. Now in a three-phase 4-wire system, this fourth wire will act like a neutral wire. Now it is going to act like a return path from source, from the source is delivering the power, and the load draws some amount of current. If the current drawn by the load is some IR by R phase, if the current drawn by the Y phase is IY, and the current drawn by the B phase is IB. Now if the system is perfectly balanced, IR plus IY plus IB will be equal to 0. Now whatever unbalanced condition is there, that current flows through the neutral wire, right. So here now this fourth wire will act like a return path for the three-phase currents when the load is not balanced. For similarly, if you are having a single phase system where the load is connected, here the load is connected, right, and this acts like a phase wire, and with the help of neutral wire it gets returned. But what about this earth wire? Now this will be actually connected to this, if it is solidly grounded, the neutral is earthed like this. This neutral point is earthed here. So here this neutral point, if it is actually, this is the neutral wire, this is the phase wire, and if you provide, if any unbalanced conditions, for example here, if this neutral is earthed, earth wire is actually connected to the general mass of the body and the metallic body of the equipment. So it is to provide the, or it is provided to transfer any leakage current from the metallic body to the earth. If any leakage current is there, that current will pass through the earth wire, that current will pass through the earth wire to the grounding system. If any leakage currents are there, that current will pass through this earth wire to the grounding system, and this grounding system should have a very low value of resistance. If it is offering high amount of resistance, then this current cannot pass through the earth wire to the grounding system. So for this sake only we are making all those arrangements to reduce the resistance of the earthing system. It should be as much low as possible. It should be as much low as possible, right? But the neutral wire just provides a return path for the current. But whereas the earth wire, it is going to provide or to transfer leakage currents from the metallic body to the earth. That is the main difference we have to observe, right? Yeah. So with this we will stop the discussion here, dear students. This is what all about the earthing, right? Thank you.